Because if I gave it, and like I like bark a little bit, you know, if I got like one little phrase wrong, then all the run up to the mic. Well, yeah, except I think this room has
That is
more
that
HTTP.
is the whole problem with this endeavor. It's
Right,
always
but
going to be vice versa.
Yeah, but I think there's way more. So the DNS people will.
There's no X's or okay. Yeah.
So yeah, no, I think the DNS
Okay.
people will have different preferences. I think HTTP will actually have technical questions. Yeah. So, but let's both stand. We can even stand next to each other in the box.
Shorter.
Better that than me behind you.
Actually, you want to go over
I'll
that?
be
Right.
making little ears and everything.
Right. Well, let's go to
The agenda is
meeting. Oh, okay. And,
Sure. I mean, I don't think doors.
Oh.
Yeah, it's close. And wait. You want So let's put it this way. I believe that it's well, yeah, exactly. That's what I'm saying. It's like I'm saying it doesn't matter. And just be clear. After both MD5 and
so the other question is, how does the
I said,
do well, right? Which I just did try to do.
I assume, so
If you would try to.
sorry, right. Yeah.
Did that work?
Wait, you're saying you're doing it the way that we have?
It's interesting.
You have a different.
Chrome full
Then
screen
don't
doesn't seem
I
to
mean, just saying, oh, we're doing it over.
okay.
Details.
I don't know that it matters that much.
Yeah. So, for example, you know, there's one in DNS which is different than others. They can do whatever they want. In fact, that's probably the one you're doing, is the one for data. That's different than ours. Ours has very specific semantics. Yeah. Okay. Sure.
Welcome, everybody.
Okay, hey y'all, we're calling the meeting to order now.
Okay, thank you everybody for coming to the very first ever DNS over HTTPS working group session. Note ye well. Everything you say is important here.
I beg to defer. One thing I'd also like to point out is we're very new as working group chairs, despite being at the IETF for a while. So please go gently on us to the extent that we're fumbling our way through this.
And we thank Tim and Ted for taking minutes and scribing. Thank you very much.
Just a quick agenda that. Well, actually, Ben's going to do the slides, and should we Here's the stumbling through it part. Let's just go ahead with that.
Share slides. Okay, this is a brief description of the present moment. If this looks unfamiliar to you, you are in the wrong room. Yes. If this looks unfamiliar to you, you are in the wrong room. We are here to talk about this. Here's the plan. We're going to briefly tell you the thing that I'm telling you now, and then we're going to hand it over to Patrick and maybe Paul Hoffman, who are the co-authors of the one draft that we have on our agenda today. We're going to hear what they have to say about the open issues on that draft. We have time to discuss anything you want to discuss about that draft. And then we have scheduled block for open discussion on all issues related to the entire concept of what we are doing here. So I would ask that if your questions are not directly protocol related, that you please hold them for the second half of the session. Thank you.
I'm sorry, I have to agenda bash. This is Elliot. I think there's an open question still as to what lands in what document. And I'd just like to note that and say, as we go through the issues, I'm happy to defer anything that I have for the second half of the discussion. However, where things actually land at the end of the day, I'd like that to happen as we identify solutions. Because I don't think what I've been raising on the list requires a tremendous amount of text, and it would be really silly to create, a 3 to 6 paragraph internet draft to address something. And I think at least one of the co-authors, I haven't talked to the other about it, but at least one of the co-authors understands what I'm talking about. So, all right.
Okay, noted. If you think that what you're discussing is directly relevant to changes in this draft, then by all means. But if possible, hold conceptual discussions for the second half of the session.
So that's not what I understood Elliot asking for. He asked that we have a discussion about the protocol and then a discussion about other topics without biasing ourselves to how that will manifest itself in documents, which I think is fine.
Okay. We can amend the last 10 minutes. Instead of identify next drafts needed, we can say identify if any next drafts are needed or whether we can do everything in this draft. No. So that's all for the chair slides. And I believe we are now over to the draft slides.
Yeah. Just to be clear, I had said we could both stand in the pink box. That's not happening. You're co-authors. You must like me. We do. Not that much.
Yeah.
Right.
All right. Good afternoon. Yeah. All right. Regain my footing here. Yeah. Good afternoon. I guess we got 15 minutes, and I aspire to stay within that time frame. Okay. I think we all know why we're here. So 3 IETFs ago, we had a little barb off. I arranged a room for 24 people. About 85 showed up. And we talked about what DNS over HTTP means to you. And it turns out it meant something different to everybody. So that has informed this work going forward. Last time around, we had a dispatch version of this proposal in Prague, and we ended up with this esteemed working group. Welcome and thank you. You got to point it at the laptop. All right. We have a draft. I love first working group meetings. How many people have read the draft? Yeah, that's got to be around 50%, maybe more. That's awesome. An 01 came out to capture some early feedback. And I think the most important thing to note is we have essentially 6 months, according to our charter, to submit the specification to the IESG as a proposed standard. So I certainly don't want to spend my whole career on this document. So I appreciate everyone's help in making that happen. There's a GitHub set up. Ben and Dave, announced this on the mailing list. There's a little screenshot of this from a few days ago. As always, substantive discussion should remain on the mailing list, but chatter always bleeds back and forth. So I would just have a personal recommendation to everyone out there to go just subscribe to the issues notification on the GitHub. It will make your life a whole lot easier. Okay. So, because we've all read the draft and we've all read the mailing list, we won't go through in detail everything that's gone on, but more or less we have three distinct categories of issues that have been opened about the protocol draft. Now, if you have a new issue you'd like to make, you can either go open it in the GitHub yourself, or you can, make a comment on the mailing list, and the editors will go do that for you if they realize you're raising a new issue instead of just contributing to an existing discussion. If you really want that issue open, you should either make that clear in your comment or open it yourself so that it doesn't just get incorporated into the discussion about something else. So there are 3 broad categories of things. They are interaction with HTTP2, interaction with HTTP caching in general, and things I've labeled possibly editorial, hopefully editorial in my mind. So I think we've identified 2 issues that are worth face-to-face time. So if I don't capture in my 2 issues for my 15 minutes up here what you want to talk about, I think that's fine because of the way we've structured the agenda here. There's another 35 minutes. So please, I think this is a wonderful use to make a wonderful use of our face-to-face time together. Okay. So one of the buckets that we've heard a lot about, yeah. So the current draft requires HTTP2 or its successors is actually what it says. So RFC 7540 or its successors. And I've tried to lay out sort of the pros and cons for this argument. On the pro side is essentially that to achieve the necessary performance with DNS data being small and highly out of order, you need the multiplexing and priority mechanisms that HTTP2 provides you, specifically the multiplexing mechanisms, right? So when Deprive went about similar work, they built in an out-of-order response mechanism, which is going to be very, very similar to what HTTP2 is going to give you in this situation. And the argument to be made here is that the end result would simply not satisfy the use case if you didn't have that property. Okay, multiplexing becomes a bigger problem as responses get large. So if you want to do things like transfers and things like that, or this mechanism, the ability to do prioritization as well as multiplexing becomes key, something just a mere head of line blocking solution doesn't have. And then the number 4 bullet down there is also really important, is that the HTTP overhead mitigation, the header overhead mitigation that goes along with HPAC and the other compression schemes may be necessary. As you look at the protocol, you'll find out that perhaps a preponderance of the bytes are actually in HTTP2 or in HTTP headers, rather, control data instead of DNS data, but HTTP2 will successfully mitigate a lot of that for you. The last argument is over there, actually bullet number 3. I apparently wrote them in a different order than I had them in my head. And that is just the notion that it is okay under some circumstances when doing new features to require best practices for those new features as a carrot. And I can think of a number of considerations where this may have made sense in the past. They may have helped move some technology forward. I already see Martin and Mark in queue. Can I go through the cons before we do that? Okay.
Let's run all the way back here. No?
All right. All right. So on the con side, I think perhaps the winning argument at the end of the day is that the scheme is largely impractical. That it is hard for, say, a JavaScript implementation of this or a remotely deployed implementation of this to be aware of the infrastructure between it and the endpoint. So you may not even know what the client is running, even if you can control the DNS API server, much less know what downgrades may be enforced in the middle. On a more positive note, argument number 2 on the con is, the whole point of, using HTTP is to rely on the semantics of it to get a widely compatible and deployable benefit. This is why we develop things in layers, and you should just put your trust in the layers. So rely on those semantics to get the full benefit of HTTP. And the third argument is sort of a counter argument to the it's okay to require best practices, to say that requiring those best practices is actually an anchor around your neck and you'll never get DOE deployed. At the bottom, I've listed the 3 obvious options, though I'm happy to hear others, which is to continue with the requirement, to have silence on the issue, which is to say we use HTTPS and not say what that means in terms of versioning, or to endorse HTTP2 with an explanation of why it is a good thing without any normative requirement. So that's my thoughts on the matter.
So yeah, let's do this now, and we'll go to the next one. I think as long as you guys are watching time, let's do this one, and then we'll go to the next one. You can tell us when we're supposed to go. Yeah.
So Martin Thompson, Paul just said we'll do this one, and then we'll do the next one when we resolve this. Is that?
Not when we resolve it, when we've sort of.
Paul, you need to use the microphone.
I can't hear you.
So yes, let's do this one, and then they will tell us when we have to go to the next one. But let's do this while it's fresh in our heads.
Right.
Yep. Let's talk about the slide.
Thanks for summarizing all of the options here. I think you've pretty much covered all the ground reasonably well. Some of these are less important than other ones. I think I originally argued for silence, but I like the endorsement, actually. I think there's plenty of reasons to recommend this, and obviously the performance is going to be less good, I will say, on HTTP 1.1, but and security benefits and all the other things that HTTP 2 brings are obviously improvements, but I would be opposed to a requirement for the reasons cited.
Actually, before you go away, Martin, so if we go to endorsement with explanation, how would you deal with the out of order question, with the responses being out of order? Would we just say you're only going to get what you get with HTTP 1, meaning you can't assume responses out of order?
You get HTTP, is what you would say. That is just a natural consequence of if you choose to do HTTP 1.1, then naturally you are forced to basically make one request on a connection at a time. You can't even really rely on pipelining working.
Right.
So, I mean, the other approach is how we always do multiplexing with HTTP 1, which is parallel TCP connections, right, up to some kind of limit. And I mean, I would note, the directions each time we've had to revise HTTP, whether it was for 1.1 or 2, have been with direct, charter level language saying, thou must use fewer connections, right? That's always been a goal of making it happen. And so to, kind of invent a new higher level protocol that's going to have that implication is what makes me a little, nervous.
So we always.
What I'm asking is, would you want words to like that effect if we do the endorse with explanation?
No, I don't think so. I think
Okay.
you would articulate the advantages of HTTP 2 and leave it there. Nothing more. I would be happy with a should, even to that extent, and use these to justify the should. I'm opposed to a must.
Right, thanks.
Mark Nottingham. I think it's fine to say if you do this over HTTP 1, you might have a bad time, and to list out the various ways that could happen. But you say man in the middle up there. I mean, a lot of reverse proxies and a lot of CDNs talk H2 on the front end and H1 on the back end. And so I really don't think it's realistic to say that, it has to be H2. You can't guarantee that. What was, I missed something. I'm sorry. What was the discussion about ordering?
I'm a little confused why my HTTP co-chair is asking that question, so I think we're talking about something different.
Well, is someone assuming that there is an implicit ordering in HTTP 2 of requests?
No, there is an explicit ordering in HTTP 1 of requests and responses. And that's not a good
No.
property for DNS over HTTP, which may want out of order
Okay.
responses. So that's-
Parallelism is a problem in H1. I think we can agree on that.
That's the point we're making.
Just please tell me that you're not assuming that you're getting the process, the property of ordering of requests out of any version of HTTP.
No, we're absolutely not.
Okay, good. Thank you. Thank you.
Ian Sweat, Google. Would there be any advantage that the spec would have to restricting it to HTTP2 besides the obvious pros that you've laid out there? I mean, is there like, would it somehow make the spec fundamentally like easier to write or easier for, I mean,
In practice, I think it's harder to deploy if you look under the con list, right?
Okay.
I mean, I think it is a little challenging to deploy if you have to limit it to HTTP2 only.
yeah, that's what I was going to comment is it's at least for our load balancers, it would be quite difficult. It would be a very odd policy for us to restrict this to HTTP2 only. And it would be sufficiently odd that I don't think we would do it because it probably would violate some rule that, you know, if thou speaks HTTPS, it better work either way or something. And same with the load balancer backend comment is,
Yeah,
so
I mean,
yeah,
that's kind of a combination of points 1 and 2 on the con side, right? It's a little impractical, and all those layers they're semantic layers already, and they're not expecting that kind of.
so
kind of
yeah, so I would definitely say this is a should. I mean, it really is should. You will probably get a really crappy experience if you don't use HTTP2
So
or
if we recast endorse with explanation as should, is this getting support?
Yeah, that is strong support for me. I mean, I think we should explain that like we really should use HTTP2, but I think forcing it is like totally impractical and probably a bad idea.
Ted Hardy, totally impractical. I actually got up in order to suggest that we might want to say different things about clients and servers, because there are going to be some servers in the future that have client bases that are H2 only, because of the deployment practice that's going to be common to them, and that if you put it as should, you could end up in situations where the mix of what's available on specific servers is unknown to clients. And I think that's a bad situation. So what I was going to suggest is say that servers must support H2 and may support versions other than versions below H2, and clients should support H2 with the endorsements that you have there. And I think that will get you the best mix of deployment. I do believe that there are cases, and I certainly understand the cases where you have a front end and back ends that are different. And I actually don't think that those are really captured unless you break out the client and server requirements separately. Thank you.
Just noting that we're closing the line after Mark so that we can move on to the next.
Hi, this is Andrew Sullivan. I wonder if maybe part of the reason that we're foundering on this a little bit is because many of the people who are pushing back against this have forgotten that this is a transport for DNS. And this isn't totally clear in the document, but I read this requirement as basically saying, well, you want to do this because it matches the operational reality of DNS traditionally. So it could be that is the way out of this, that if you do the should or something like that, in order to make it clear that the reason why this is the case is because DNS operates this way today. It's got lots of stuff in flight. And I think that could be, this is going to really suck if you try to do it over 1.1. Thanks.
Whoops, John Levine. I mean, to me, this feels a certain lot like refighting the use case arguments by proxy. If you want to make everything, if you want to keep evil people from spying on you, you need HTTP2. If, in my case, I just want to look up some SRV. Sorry. For some use cases, you need HTTP2. Like if you want to keep evil people from spying on you, HTTP2 is much more helpful. In my case, I just want to look up some SRV records, so I don't really care what the transport is. So I think, endorse with explanation is plenty.
Mark Nottingham. I don't think a should is appropriate here. When people read standards for better or worse, they see should, and then they use that as a bludgeon to beat people over the head with. The pros that you're listing here about multiplexing and about header size assume a certain deployment scenario. The reason that a lot of reverse proxies haven't done H2 on the origin side is that they don't feel they need it. They're using other techniques to get multiplexing and to mitigate these effects you're seeing that aren't used commonly by browsers. And so I think if you want broad deployment, then you need to not cut things off arbitrarily. Also, the HTTP working group, you might be aware, has just adopted a document that talks about how to use HTTP as a substrate protocol, revising BCP 56 bis. And when Andrew says things like HTTP as a transport, I bristle and I get concerned about building that double hourglass. And I think Roy Fielding just woke up and screamed into the night. So you'll get that feedback too if you go that way.
So I will take this away as we will come up with some wording. I'm not sure if we'll say should or not, we'll do that, but that this is still open, but towards endorse with explanation.
And maybe that is a good time to slip in the PSA for BCP 56 bis, because I think the group should actually know it's not coincidental that the HTTP working group has taken that on at the same time as DOE was formed. And it is one of my personal objectives, to have DOE be sort of a good poster child for that work of best use of HTTP as a substrate. That being said, we have just adopted that document and it is not a final thing, so we have a chance to sort of come up with that final resolution informed from each other. Yeah.
Oh, right. It doesn't work.
Okay. So the other thing I wanted to make sure we talked about, though I'm sure we'll talk about a lot more, is this bucket of issues regarding interaction with HTTP caching, which is not extensively defined in the document. And this is kind of thematic with the last set of questions of whether or not it really needs to be. Does HTTP already define everything we need to know? So you can see these go from the concrete to more abstract. Issue 13 is the most concrete, and I've actually already put a tentative resolution into what will be the next iteration of this draft. And for that, it's talking about the HTTP freshness lifetime should be the shortest TTL of the response set. So obviously you can have, multiple resource records come back with various different TTLs, but they're all coming back in one HTTP response. So the resolution on this is rather than just saying it should be the shortest of those, that it must not be more than the shortest of those. So saying it can't be greater than the min. The other issues here are, and that's already committed, but as we talked about before, anything that gets committed off of GitHub is nothing other than an iteration of an internet draft, does not necessarily reflect consensus until we get consensus that will be declared by the chairs or through last call, right? But that is just, in the survive in advance, just trying to move forward model. The other issues are a little more abstract. They're saying, the document doesn't specify a particular caching model. How does the DNS cache interact with the HTTP cache? How does that interact with the recursive resolver? I think that's kind of implicit in there, but we can talk about that some. And finally, the draft does discourage HTTP revalidation, given that it's fairly impractical for a bunch of these use cases. Although I've had a conversation with Martin that makes me think we shouldn't be quite so firm on that topic. So that's my setup. Welcome, Mark Nottingham.
Mark Nottingham. So issue 13, I think that's fine. I think I want to get in there and wordsmith exactly how you specify it. So, if you do it in terms of the TTL, I want to make sure that if we have further extensions to the caching model, it will be compatible with those. For example, if we one day define an invalidation protocol, it should be able to slot in with this really nicely.
Yeah.
So and I think that's just wording.
The caching model of HTTP.
Yes.
Yeah.
Yes.
Well, obviously pull requests, accepted. The notion there, I
Is
did
that a
try and
promise?
hang around the language of freshness lifetime because that seems to be the most generic way to express
Yes.
that.
Exactly. And because that's the core concept. Regarding 14, I think you're right. I don't think we need a specific one. We just need to describe the interactions where appropriate and put the appropriate caveats around, here be dragons where necessary. And issue 15, Is the discouragement a RFC 2119 kind of discouragement? It's just text?
It's actually a little stronger than that.
Okay.
But it's non-normative, but it's,
I think, generally, maybe we should have a discussion about principles in that, especially when we're talking about how we profile these protocols, illustrating why you might have problems is great. And exploring that space is something we definitely should do. But just preemptively saying, don't do that is perhaps
Yeah.
too much.
the current text uses a non-normative should, which, tickles all kinds of buttons. And so clearly
Really?
we want to tweak that a little bit.
Okay. I think that's probably too strong. And we should just explore the space.
So, Martin Thompson, the reason that I opened issue 14 was because I had some questions about how this worked in practice. If I'm going to try to use some of the HTTP caching semantics, they basically get swallowed if there's a cache on either side of them that's applying the strict TTL rules. And so there's not a lot of value that we're getting from using HTTP caching in that model.
Do you think that's true when the HTTP cache is a shared cache between clients?
Well, why would the DNS cache not equally be shared, is the question.
Because they could be in two different clients.
Okay. You're talking, I'm not aware of one of those, but maybe, okay. Even still, it's, you would get the sharing at that point, which means that you would get through the first cache because it's not there, and then it would hit the second cache, and that one's shared. Therefore, it's more likely to have a hit. Is that
You would
your
get the
assertion?
sharing in the second layer cache? Yeah, that's mine.
Yeah. Yeah, even still, I would like to have a little bit of clarity about that because I had trouble answering the questions that I had regarding this. And someone suggested to me that maybe finding ways to bust that first cache might actually be of value. And then again, I'd like the opinion of folks who know DNS more. Is cache busting a thing that we actually want to have? Because HTTP provides numerous ways to deal with that. And if HTTP is going to be involved in this, and we're going to be relying more on the HTTP cache for these things, what are the implications of people using those techniques on things like, say, server load?
So in the DNS world, we pretty much are in denial about this. That is that the server gives some TTLs, and those are understandable. And what the client does with those is really a local policy. Many of the local policies are to follow it. Some of them are to follow it until it looks like it's going to expire and then preemptively renew. Some of them are to say, I know my number better than theirs. I'm just going to stick my number. And those are all very common. So in the DNS world, we actually just assume that it is advisory, and that it's not nearly as tight as it is in the. Yes, you do actually. So, okay. I mean, we've had this discussion in DNSOP many times on many drafts. So in fact, we are just living with it.
Ben Schwartz as individual contributor. I think that the logic in the draft works for me, but it took me a long time to understand that logic. As a simple-minded person and implementer, it would be really nice to have a couple of extra sentences explaining things like when you might rewrite the TTL on an HTTP to DNS conversion. So it seems like if you're there are certain models where you pull an object out of the HTTP cache and you actually have to sort of shorten its TTL before handing it downstream.
Right. So the HTTP caching language is fairly extensive, shall we say? And it has, as I've been talking more with folks from the DNS operations community, I've had to explain some of the finer nuances, like the age header that a cache actually knows, the difference between now and when something was generated, how long that's been, and can make that part of its TTL. And I think perhaps exploring some of that space could be a useful contribution here.
So Ray Bellis, ISC. Yeah, I kind of have to take some issue with what Paul just said. Yeah, TTLs are supposed to be, sorry, yeah, just did, sorry. Most clients should be treating the TTL as an absolute maximum. Notwithstanding, there are some that do. But if, for example, we get an HTTP packet, sorry, a DNS packet that comes back from the DNS server that says the TTL is 300 seconds, and that then goes through into the HTTP caching headers that says, well, you can remember this for 300 seconds. And then 299 seconds later, somebody else gets the same response back. They've essentially doubled the TTL of that record. And
So
that's
I'm sorry. So that's actually just what I was referring to. So that's the age concept of the cache.
Yeah.
So when that response is served from the cache in the second iteration, it's served with an expires time of 300 seconds, but it also has a age of 299, and it's in HTTP rules. It's required by the client to do that subtraction to know that this
Okay.
response only has a 1 second lifetime left.
so relying on the HTTP layers to override what's in the
When you're using HTTP caching, you are relying on the HTTP. And the whole point of issue 13 is that the HTTP caching semantics are consistent with the DNS
Yeah.
TTLs.
Yeah.
Right?
Yeah, I mean, notwithstanding that a lot of people treat TTLs advisory as a maximum, I think we should be very clear that so far as possible, we do not extend the TTL records, because the TTL on DNS records are actually for the zone administrator's benefit and not for any downstream user. Downstreams are free to use something lower, but they should never go higher.
Yep, this is consistent with that coming through the HTTP.
Ralph, before you go, may I interrupt for one moment? I
Yes, go ahead.
beg your forgiveness. The one aspect of this that I want to point out too is that essentially this is blessing Unbound. Unbound is a particular DNS implementation of a recursive resolver, and its caching model is one that uses the DNS message as the fundamental unit of cacheable information. And that's kind of contrary to what the DNS people expect as an RR set being the fundamental data unit for caching. And so that leads to interesting second order effects where a lot of things get requeried well before they need to be requeried. For example, a CNAME chain that has 2-hour CNAMEs in it and then ends with a 20-second address record will end up being requeried the entire chain every 20 seconds instead of based on the RR sets of the CNAME. So.
Yeah, and our favorite nominum. So, I mean, DNS caches on the left side can be sort of magnitude of orders of forwarders. And I'm not sure if that's also true in the HTTP world, but you have to make sure that you have the shortest time of all this stuff in to make sure that the stuff is fresh. And one more question, because I don't know the HTTP stuff too much. What would happen if I give back a TTL of 0? Because that's, I mean, unfortunately getting more and more common in the SRO also.
So that response would be useful for the request that made it, but would not be used for any future responses.
So effectively no caching.
Correct.
Okay.
Whoa.
So if what he said is not true, then that should go to the HTTP working group.
So, wow, many things.
So I would just want to note for people listening online that might not have heard the general groans in the room that just followed that assertion. That
Yeah.
there is apparently some disagreement there.
So, Warren Kamari, a couple of things. When DNS people publish a record with like a 10-minute TTL, they generally sort of double it or so for assuming how long it'll actually be used because of things like forwarders.
But be careful when you say they. When a server publishes with a 10-minute TTL, please finish the sentence.
Yep. The person who operating the server assumes that the record will stay around for sort of 20 minutes or sometimes 30 because there are forwarders. And with forwarders, you just take the TTL and you store it for that and hand it back. So if there is a forwarder and an HTTP cache and then another DNS thing behind it, yes, if it's being cached for sort of supposed to be 300 seconds, being cached for 299, maybe that TTL should be changed to 1 if it's handed back to anything that will ever end up in the DNS again. But we need to just think about that. Another thing which needs to be kept in mind is there are various records that actually expire at a time. Things like DNS keys, ZSK, KSK have an actual wall time at which they expire, and that needs to be kept in mind as well. And I can't remember what the third thing was, so I will assume it wasn't important, and we'll sit down.
Stay there. So you have two things. One is the first one you said was maybe the HTTP server should change the TTL in the record. The second one is we have some wall clock things. Okay. I would like to respond to the first one. Our model so far in the draft has been that the HTTP server is passing along DNS data. If you want something different, please suggest text. Yeah. So that's, you're changing sort of a fundamental thing here, which I'm not saying you can't do. I'm just saying that that's the first we've heard of that. Second one about the wall clock, again, we are passing things through. There's nothing in here that says if you are passing, say, a DNS key record that has an absurd wall clock time in it, like something in the past or in the future, you should do anything. Again, the idea is we're passing things through.
So for the first one, I'm not saying we should necessarily change it. I'm just saying that if it changes operational stuff, whoever's doing this should, be aware of that. Maybe changing the record, the TTL on the record is useful. Maybe not. More discussion.
Right.
On the wall time thing, what I'm concerned about is a record arrives. No, it should be okay. I was concerned a record would end up in the HTTP cache way after it had expired and would continue to be served.
Just in the same way that a forwarding chain might have done that. We believe that this is like part of the forwarding chain. If not, we need to be specific.
Jim Reed, RTFM. If we're going to have DNSSEC in this kind of scenario, Paul, what would we do about DNSSEC validation type issues? And I'm also thinking in the cache issue about aggressive NSEC caching.
We are going to do whatever. If the authoritative server, if the recursive server who you're talking to is doing validation, it's doing validation. If it's not, it's not. I mean, it's no different than the current state.
Okay.
Yeah. We're trying to be not special.
Okay. You leave yourself wide open there. Mark Nottingham.
Mark, you can be special.
Oh, Paul. Listening to the comments, I think it's safe to say that we're kind of witnessing a little bit of a collision of cultures in that there are some people in the room who are very fluent in HTTP caching and don't know a darn thing about DNS, and I feel like that. I think Patrick probably knows more about DNS than I do. He's squinting. And other people know a lot about DNS and have a lot of context there and don't really understand HTTP. And so I think maybe we can look at a couple of different ways of improving that. If the spec were to contain a number of worked examples of the messages on the wire in toto, as well as the deployment scenario, that would probably help. If the draft were to be extra careful about its terminology, because I've already heard a bit of confusion about caching and different things. And finally, if we can do a little bit of education, I mean, I'm more than happy to arrange to give people an HTTP caching tutorial. I can do that, maybe in London or whatever. And if somebody could do it on the DNS side, I sure would appreciate that personally.
I would love to have those happen before London, since we are sort of on a short leash. If we have a virtual interim before then, I think that those two tutorials would be really good. I would not give the TTL one. In fact, I might make Ray do it. But yeah, I think that would actually help these issues. And as for the examples, I just did a quick check. I think worked out examples with times in them would actually be really good, because if nothing else, that would shock some of the DNS people into understanding what we do ourselves anyways. We don't have worked out examples like that in any of the DNS RFCs. Okay. And as for being careful about terminology, I'm going to switch hats quickly. RFC 7719 is DNS terminology. That is being revised in the DNS Op working group, and I'm the author. So if any HTTP people are reading either 7719 or terminology BIS, and you say, oh, I was expecting this to explain this about DNS to me, and they don't, please speak up now. We're going to be in working group last call on the BIS soon, and this is exactly what this document is meant to help.
Okay. Can I make one more request then? In the HTTP world, we have a homepage, httpwg.org, that has a listing of all the relevant specifications and current specifications for HTTP. And so if you want to understand part of HTTP, you can get the correct reference at least. I can't claim that it will make you understand HTTP, but at least you can get the correct reference. DNS, I'm sorry to tell you this, is very confusing from the outside.
So you haven't read 7719 yet,
Obviously.
because one of the things when I started it eons ago was let's just define things. And everyone's like, which RFC is that coming from? It is full of this thing is defined in these 2 sentences, but if you
Okay.
want more, here's where they're quoted from.
Okay, so can we use that as a roadmap to understand modern DNS? Is that the right
Yes,
place to start?
that's one of the intentions.
Okay, and it's 7719.
Yeah.
Thank you.
And I'll send that to the mailing list. And
Please
I'll send
do.
the pointer. Okay,
Thank you.
and I'll send a pointer to the, oh, did you already send a pointer to the BIS? Great, already done.
Well, I'll send a pointer for the HTTP stuff.
Thanks.
Okay, and now Mark Andrews is joining us from the Meet Echo queue.
Warren was talking about forwarders. They all count down, or otherwise they're broken, which means the entire forwarder queue will expire the record or the RS at the same time.
Thank you, Mark.
Yeah, John Levine, I would like to strongly endorse the suggestion that we work out some examples of how the caching interacts. I mean, because I can imagine a way to use the HTTP date header to adjust down the TTLs in the received data in a received library, which seems too ugly to live. But I'd like to make sure we all agree that we either do or don't want to do something like that.
Yeah, I think we're pro examples, but actually the example you cited, HTTP prohibits, but.
So Martin Thompson, I wanted to sort of applaud that. Please send the 7719 BIS link to the list so that everyone can find it.
Tim
Thank you.
has already done
Thanks, Tim. Oh, even better. I can send PRs. No, I won't. I promise I won't.
No, promise that you will.
Yeah.
This really is one of the reasons we have done that. And no negative on Mark about the homepage for HTTP. This is, DNS is hard for outsiders to understand. And this was one of the reasons we did this. And if it's not fulfilling that, you all here, are on the bleeding edge.
So we talked about revalidation briefly. Was the conclusion there that we would say virtually nothing about revalidation? Because I think there's some interesting things we could do with things like stale while revalidate and those sorts of things in this space that would be really interesting.
Yeah, I think we can, as Mark said, sort of explore the space. I don't know if there's anything normative we want to say, in terms of how you use this. I think this is going to be one of those BCP things where the draft as it is discourages revalidation. It probably shouldn't do that. HTTP is what it is, and 304 is what it is, and if modified is what it is, and so we really shouldn't say anything strong about that. But exploring the interactions between stale while revalidate and exploring the interactions around what does a 304 really buy you in terms of like byte size versus the actual DNS thing and all that. I think that's worth spending some text on.
Yeah. So the point was made about RR set caching as opposed to message caching. And have either of you put any thought into the splitting of RR sets out?
So
and using something like, say, push, which then you could...
Wait, splitting them out where? What do you mean by splitting them out?
Splitting them out into separate responses.
So, Martin, yeah, so Martin is suggesting that the DNS API server would extract the minimal RRs from that RR set. Is that kind of what you're getting at?
I'm a little fuzzy on the specifics, but there's always the related things in.
So since that hasn't really been discussed in the DNS world, I don't think it would be good to start it here.
Okay.
Yeah. And
That's
now
a
that
fine
you've
response.
said it, you have infected like the DNS people in here, and I'm sure we're going to start getting drafts in DNS op next week about this. But for now, no, we haven't discussed that. And boy, would like to continue not to.
No, I like it. So I mean,
St. Patrick likes it.
Yeah. Well, anytime you use push in a clever way, I like it. For
some very large, clever.
I don't like traditional implications of push, but I think this one's really interesting because it allows you to split n records into the one you want, which is your primary response, and then n-1 pushes as your additional records. And you can give them individual
freshness times. That's what I was getting
That's
at.
really sexy, Mark.
Yeah.
Right. So I just want to point out visually, one of the two co-chairs of DNS Op is sitting here wincing and possibly crying almost. Yeah, just a little bit dust in her eye, right, from the future of this sandstorm that's coming towards us. So no, we haven't done it. If the DNS Op working group gets ahead of us on this, it would be part of this. But no, again, let's not try to change the way DNS is working just for this.
This is a fine response. I just felt beholden to inflict this upon the working group as part of Mark's culture clash theme.
Yeah, I do find the culture clash thing interesting. I would have never thought of that here. I would have thought you would have thought it was a bad idea, and the fact that my co-author got excited about that, yeah.
Ben Schwartz, I just want to point out that probably is not application DNS UDP wire format.
Right. It would be wires format. Right.
Well, and now I also want to observe that we're actually have been well into the time that we just left for general discussion on the draft. The mic line is empty at the moment. Did you have more you wanted to say before we went into just general draft discussion?
I think that was our last slide.
Right. I thought so too.
Yeah. So yeah,
which is why I didn't stop the discussion.
Are we excused?
No. He's asking.
No, you have to stay here to get whatever else now people want to bring up about the draft.
So are there other issues about what we've done, the protocol draft at this point, since there is the other ones? Are there, we just opened up cans of worms, but are there other things that people who have been reading the draft are current, want to bring up right now? Because I think there's plenty more to be discussed in the second half. So I think you're free, and I'll follow you.
Okay. Thank you very much to the authors. We don't exactly have slides. This is now an open discussion, and the question here is, what other technical issues should we be addressing beyond the contents of this protocol?
So, Ray Bellis, ISC. If this is to be implemented using, for example, a front-end HTTP proxy, which is then talking wire format to a downstream server, I have a draft in DNSOP called Draft Bellis DNSOP XPF, which is for carrying the original client's transport information, for example, their IP address, ports, and so forth, to the back-end server. This is just an appeal to get more review of that draft, please, because we're hoping it's going to have a call for adoption around this. I do want to get that adopted, and the HTTP proxy is a perfect use case for this. It's intended only for server-side proxies or protocol converters, and it just needs more review. So, thank you.
Hi, this is Elliot. So this is a follow-up to the email discussion we've had on list. There were basically three issues that I raised on the list. The first was that had to do with split DNS and how this worked with split DNS as an operational issue. The second had to do with global server load balancing. The third had to do with security appliances and tools that actually use DNS in enterprises relating to trying to prevent malware or detect malware. In discussions on the list, what I think we found at least some common ground on one of those issues. I think Mark had a suggestion, at least, to point out in terms of how we deal with global server load balances, global server load balancers. In just private conversations with some of the people around, it seems like there's an easy way around addressing split DNS in terms of at the bare minimum a configuration point in terms of understanding what's local versus what's not, so you know when you don't need when you can't really use like a DOS server that is outside some proxy boundary, for instance. And the third issue around cybersecurity and doing scans of the DNS packets, looking for packets, I think, looking for malware, I think that one sort of remains open, but the one suggestion I think I saw on the list was, well, we just don't use it if this is the thing that you are worried about. My point in all of this is, I think probably there's, if those are the three issues that anybody could think of around this, I think there's probably just, a paragraph or two at most that we could probably add into the draft. And I just suggest that I create a pull request and people can review it and then decide whether they really feel the need for for somebody to publish a large internet draft for a 1-paragraph issue. So that's what I wanted to mention. If there are, I meant to mention these things as issues. They can be resolved in various different ways. Some of them are, as simple as, what was suggested, which is, have a manual configuration. People can explore things like proxy packs or not. That was not meant to, I don't feel the need like we have to solution engineer absolutely everything here for this, but just to, mention the issue. And even if we have one simple approach to get around something, then that should be enough from an operational consideration standpoint. And if people want to get further, more elaborate about it, that's fine too. But we don't have to, not all that has to go into a draft. The draft is relatively compact, it's relatively well written, and rather not, disturb that with lots of operational stuff. But if we can keep a paragraph or two small, to address these things, it's not uncommon to have in our RFCs, some operational consideration discussion. If it's compact, if it's a whole model or a whole new deployment approach, then yeah, you fork that off into an internet draft. So I'll stop there.
Patrick, are you going to speak to editorial concerns about the structure of the draft in relation to this?
I think it's a working I don't have to be asked twice to hug the microphone. Sure. I mean, I think most of the considerations brought up are probably similar things to what, DPRIVE had to consider. I mean, most of these things are a matter of if your recursive resolver is different than your default recursive resolver, what happens, right? And I was just actually trying to call up the DPRIVE draft and say, what did they do? And I'm sure I would say my interpretation of my 10-second read of that at the mic, but I'm sure other people here have actually probably lived through that discussion and know better, but it didn't look like they did very much on that topic. And so to the extent that this is just really a question about, who your recursive resolver is or whether or not you're encrypted, I'm happy to give a sentence or two, like literally, I mean, if there's a paragraph we can write, but given how much time is spent at the mic on the topic, I'm a little concerned that we'll be able to get it into 2 or 3 sentences, right? If it goes more than 2 or 3 sentences, I really do believe that's a distraction in a protocol document if it doesn't have a lot of implications for how you implement the protocol, and we should consider, doing that separately.
So if I may just respond, I was just going to say, just on that point, I'm perfectly happy to negotiate with you between 2 or 3 sentences and a paragraph.
And so as kind of half a hat as co-chair, I know that one of my own personal concerns from the DNS world perspective has been the greater ecosystem in which this gets used. But I see that as a separate document from just how can we describe the protocol and what the protocol should be doing. And, and to the extent that my concerns about the greater ecosystem and its applicability are something that need to be documented, I think it's going to be quite a bit more than just a couple of paragraphs.
Hello. Sorry, this is Stephen from Rakuten. I'm totally new here, so please correct me if I'm wrong anywhere. So I was trying to think that based on the security implementation of DNS over HTTPS, the underlying protocol HTTPS, relies on PKI basically in that sense. When we want to validate whether a certificate is valid, so we basically have to put the trust on the certificate that the HTTPS server presented in this situation. Now, most of the CAs, most of the commercial CAs basically rely on HTTP or something similar to basically publish the CRL or using OCSP in that situation. So basically, we now have a circular dependency here because unless we're saying, okay, we're not totally replacing DNS. We're just basically using it as an addition. Otherwise, we have a circular dependency here that says you need DNS to resolve those names in order to pin on that trust. But now there's no mechanism for you to validate whether that underlying DNS is, well, of course you could use DNSSEC, or you could potentially define a special CA that uses IP address. Yeah, or you staple it in some way. But then how exactly, I mean, do we actually looking at solving this issue, or is there any other ways? Because if we staple it, I mean, and then we go back to whether there's a new certificate issued for the same thing, and the client would have to be updated in some sense. So, yeah.
So Martin Thompson, I think there's a really easy answer to this, and the one that Patrick just said. OCSP stapling means that you don't have to go to another server to get the answer that you need. And so if it might actually make sense for us in this group to even mandate the use of OCSP stapling in this particular context, simply to avoid that circular dependency. Otherwise, we end up in a situation where you have to use some other form of DNS, or you have to not worry about revocation for the period that you're going off and searching for the CRLs or OCSP responses. OCSP stapling is good practice, and so I don't feel particularly uncomfortable about recommending good practice. Does that help?
Yeah.
As opposed to HTTP2, yeah. And now I've forgotten what I was up here to say.
Adam Roach, hat off. One of the things that I wanted to point out about the operational considerations that have been brought up is that some of these are likely to have proposed mitigations that actually bear on the implementations. So, for example, if you were to have a recommendation that implementations have exceptions for local domains in some way, putting that off into a separate document, I suspect, would probably not get it read by most implementations. So I have some sympathy for the prospect that at least some aspect of this is likely to be useful in the protocol document itself. So what I think I'd like to see is like putting together some text about what this is, what these considerations will look like, and determining whether we need them or some of them in the protocol document before we sort of rule them in or out of scope sight unseen.
Mark Nottingham. Taylor, you mentioned an ecosystem document. Could you expand upon that?
Document?
You mentioned having an ecosystem document.
Well, not that one exists.
No, but you have something in mind, or?
Well, so
Mike.
So there are a number of questions about the data authorization model, right? The integrity of the DNS and different aspects of, are we, like right now we're essentially defining a protocol that could be the norm for now HTTP servers to push down all kinds of DNS data into a client and say, oh, hi, even though I'm example.com server, I'm going to tell you about adserver.com. And we're not defining anything right now about, pulling in same origin model or whatever else that's in this current document to talk about how do we know whether the data we're getting is trustworthy. Now, there is the one aspect, certainly, that if you're configuring a DNS over HTTP server to just be like a resolver that you're already trusting blindly in the current system, that's one thing. But if there's the possibility that this is a mechanism that is going to be used to introduce DNS data to a client, I want to see that area fully explored about what all those implications are, especially with regard to the way that current DNS operators work and the expectations they have about how their data is getting used.
Sure. So I am only aware of one use case primarily for this to start with, which is user configures manually somehow, just like they can configure an alternative resolver, they configure a DOS server in their software or their OS, probably in their software to start. If it's going to be something that's, I know there was a big discussion in chartering about JavaScript somehow having some secret mechanism to do this. I think that's a red herring, because that would have to go through the W3C and be specified as an API, or one of the browser vendors would have to actually think it was a good idea to do that, and I don't think there's any evidence at all of that. I'd love to be proven wrong.
So I'll interrupt and say that the conversation that you and I had in Toronto was that there was evidence that browser vendors were interested in bypassing DNS latency times by being able to serve DNS data.
Wow, your memory is so much better than mine. It's all that drinking.
JavaScript was not part of that conversation.
No, JavaScript. Well, good. Yeah, well, sure. I mean, performance is always of interest to people running websites for well understood reasons. I just wanted to remind us that our charter says we will coordinate with DNS op and int area. So I'm wondering if there is a joint document or some separate document that might evolve out of that. And also part of the charting discussion was a huge sidetrack about discovery mechanisms, and I'm wondering if anybody is proposing a discovery mechanism document, or whether it makes just sense to write down that initial use case and say that's how we're starting.
So on the charter, I will note that we don't have the text here, but I will note that the text of the charter says that we are chartered to define mechanisms for discovery of DOE servers similar to existing mechanisms for discovering other DNS servers.
Can you scroll down a bit more? May define mechanisms. I hope that's not being interpreted as a requirement to do so.
So I don't think there's certainly not a requirement to do so here, and I think there's also some question about whether some of the more far out mechanisms that we're talking about are essentially dissimilar to existing mechanisms for discovery.
Right. I think my understanding of that discussion was maybe somebody might want a DHCP option to discover your local DOE server, which seems really weird to me, but somebody wanted to talk about it.
Adam, do you have a relevant hat comment here?
If we're looking at relevance of this on the charter, I would encourage everyone to read all the way down to the if and what comes after that. Right? This is definitely an optional part of what the working group might do.
So Martin Thompson, two things. So to Elliot's 3 points, I think we're blowing that up way out of proportion. I think if we see Elliot's proposed text, it will make it very, very clear. However, I would caution that taking on the people who want to look at what's in the packets question is going to blow it up more than we already have. And so we should probably avoid that one. The second one was the concerns about configuration or random servers on the internet sending me DNS responses, which sounds kind of scary. This is a fear that is grounded in some reality, at least, in that I now have a client that is going off and talking to servers using the protocol that they can use to make those things appear, right? So we need to be a little bit careful on this front. So I've got a web browser, I go to a site, and it pushes me the well-known with a request for some DNS request in it, and it provides what appears to be a legitimate response. What am I to do with that? Well, obviously you just don't do anything with it, but there's questions here about how people are how people are approaching this particular situation. Now, obviously, if you've configured a particular server as your DNS API server, you're not going to have that response that's come from some random server somehow appear in the cache. That's just not going to happen. So I think we're safe. No problem. But we need to we might maybe sort of make a nod and a wink in the direction of that sort of thing, because I do know that there are people who really do want to do things like push those things for their own servers. So I'm talking to a particular server and it says, oh by the way, here's an alternative service you can connect to, and by the way, also here's the IP address of that thing. Save you the time. And that's the sort of thing that I want to make sure we're really crisp about, because if we're not crisp about it, people will do those sorts of things. And I'm sure many minds were blown in the process of thinking about that and trying to work out the ramifications. I'd rather not go there just yet. Maybe eventually, not right now.
Hi, my name is Andrew Sullivan. I'm a little concerned sitting here that we're putting the cart and the horse in the wrong order, particularly worrying about, like, is it one document or 18 documents or something in between? It became very clear to me in the earlier discussion around, for instance, how caches are going to interoperate, that we have two sets of people in the room, neither of whom speak the same language. And I think the best way to work that out probably is to work through a bunch of worked examples, whether they go into the document, whether they go into another document, whether we do them all on the mailing list and then decide this should be on a web page somewhere. I don't really care, but I do think that we'd better work some of those things out in detail pretty promptly, or we're going to continue to founder on this. This example, for instance, of data showing up kind of randomly at a client from some DNS thing somewhere and it being accepted, maybe sounds really weird if you're familiar with HTTP, but if you're familiar with the history of the DNS, that's not weird at all. It happens all the time. We call it poison. So I think that that's something that we want to work out in a certain amount of detail. And again, I think the mechanics of what document this goes into and so on, we should put that off until we sort of work out some concrete things. Thanks.
Couple things. One, Pat McManus. Pop the stack back to certificate revocation. We talked about maybe recommending OCSP stapling. I think we've seen that different clients do revocation checking differently. That's one of the different ways, Paul's not at all, but that's not my browser. In any event, and much like other things about HTTPS, we would not specify, like what routes you would use or any of those good kinds of things. Perhaps not go into the details, but we could explore the fact that if you do this wrong, there is a loop. And hey, with not at all, you got to admit there's no loop. Okay, and then to pop the stack back to what Taylor was talking about with other operational considerations. I had thought during chartering we were pretty clear on the resolution of like what this would cover and what wouldn't cover. Clearly the case for recursive resolver is the primary use case. We're all on board with that. This question of, JavaScript and the thing about the W3C, well, you don't really need the W3C if you're just going to directly, use the HTTP methods specified in here. You can just do it out of fetch or XHR. But as Martin said, you don't have to worry about those answers ending up anywhere, whether they be mistaken as IP addresses by other parts of the system. JavaScript just does not have those kinds of privileges. I would not worry about it. We can write a sentence that says that, but I would not worry about it. And then the third and interesting case that's always lurking over everyone is what happens if this website pushes me these unrelated addresses, right? In my view, that is clearly not something that DOE directly enables. It would be a spec it would be an HTTP spec violation, because HTTP defines how you decide where you get your information from an origin on. And that is generally through DNS. We've recently added an extension proving that we really do define this, called origin frame, which is a slight twist on that matter. And you could conceive of the group, Mark's looking at me like he doesn't think origin frame is a twist on the DNS, which is interesting. Okay, and you could conceive of, DOE given information becoming something else that the HTTP group would want to consider for routing information. But DOE does not enable that by itself. That would be an HTTP decision. It's not been made. There's obviously a ton of stuff to consider in making it. So I would want to make sure we didn't write logic that said, this could never be done, but we can certainly say this does not enable it. I hope that's clear.
Yeah, I hear a lot of people scared that other people are going to be confused. So I think a little bit of clarity and maybe using the words to the effect of "don't poison yourself" might help a lot.
I would like to point out that when we had the BOF in Seoul and the 85 people showed up for the room for 24, and as you observed, there was a lot of different impressions about what DNS over HTTPS would mean and what that implied. And so I do think that clarity around that, saying, no, this is not supposed to be a mechanism to poison your cache, is useful to pursue.
What Do you think what I'm saying is that appropriate level of clarity or not?
No, I was agreeing. I heard you saying that we should probably just add clarity here.
Yeah, and it is what I described, and this is really an editorial question at this point, is what I described the kind of text you're looking for?
Yeah, I think it's a good direction.
Okay.
Mike Bishop, Akamai. So a lot of what I got to say echoes the previous comments that when we're dealing in HTTP with the idea that's been floated around of pushing DNS resources, well, probably if you were going to do that, it would have to be DNSSEC because otherwise it is poisoning your DNS cache. But the origin extension to HTTP2 also means that we rely less on DNS for that. And so the use case where we wanted to push DNS records has largely gone away if you implement origin. So, well, you have solved one of the major use cases to some degree. Fine. So I think the charter fairly clearly rules that out. I think we're mostly done unless we just want to say in the spec that it's not intended for the following use cases.
Eric Klein. I wanted to ask an implementation question sort of that may be too early and also will, of course, betray my deep and abiding ignorance. Well, late last night in some conversations about DNS over TLS and DNS over TCP sort of things, the question of pipelining many queries to a server yielded a result where, like, what happens when the server sort of has too many of your queries, right? And in HTTP, we have 429, too many queries, but I don't know what we really do in DNS.
They just get dropped.
But in a persistent connection, do you wait for the connection to be dropped then and closed? Do we?
Very implementation dependent. There's definitely nothing defined in the protocol to say what should happen there.
And there's nothing that would help here, semantic wise, on the HTTP side that would make things clearer.
Yeah, go ahead. Yeah, so Martin Thompson, HTTP2 actually has a bunch of mechanisms in it to sort of protect against this class of attack. It limits the number of concurrent requests that you can make. It provides very specific control over things like buffers and all compression state and all of the things that a server might have to exhaust in the process of actually dealing with all of those requests. So I think that here we have a reasonably good story if we go with the endorsed version of the protocol. And I think other than that, we're still in the wild, wild west.
The other one is just one at a time anyway,
Yeah,
right?
yeah, HTTP 1.1, we probably want to go back to the rules in HTTP 1.1 about the number of connections because that's really going to limit the number of requests you can have concurrently. And I mean, the actual number varies, but it's 6, 16, 2, pick a number. It's not really specified, but there's text about it, and anyone who creates 1,000 connections to a server gets what they deserve.
Thank you.
Lorenzo Cludi, I have to say, I don't think other people will be confused. I don't know enough to say that, but I do know that I'm confused because this text is I don't understand, for example, if I'm the web server, for example, .com, and I've certified myself as such, can I update the Quad A record, for example, .com? Yes. No. No. Okay. So where does it say that? I see. Where does it say here that work is out of scope? Is it out of scope or is it not out of scope? It is not out of scope.
Well, Hoffman, it's not that it's out of scope. It doesn't work in HTTP. You're going cross-origin and such. If you haven't asked for it, you just don't get it. Then that's what we're talking about. We might need to clarify that a bit more. It's not that it's out of scope that we don't want you to do it. That's just not what we're doing.
Okay, so then what does it mean down there that says we can define mechanisms may define mechanisms to, where is it? To discover recursive resolvers? Are those mechanisms going to be, because like today that
to discover recursive resolvers that you want to use. It's not just that, oh, look, here's a recursive resolver. In the same way in the DNS right now, there's lots of open recursive resolvers, but if somebody was if a DNS stub resolver said, "Oh, look, here's an open recursor. I'm going to start using it now," which is, you know, a completely insane thing to do. They could probably do that here, and we're not endorsing it, but we can't prevent somebody from doing insane things, saying, "Look, I found a glass of water on the ground. I'm just going to drink it because I'm thirsty."
But perhaps implicit in the words recursive resolver, recursive resolver that you want to use for all domains, then, because
Yes, that is complete. Yes.
Okay, so maybe I just don't know what that means then. So recursive resolver is something that you're going to use for everything.
Generally in the DNS world, that's absolutely right. Your DHCP server gives you an address.
No. I think I know how it works in DNS. It just it says similar, so it's like I don't know what is or is not in scope. That's
Okay. Before Elliot explodes, I think he should jump.
Yeah. Can I make a suggestion that let's have this discussion when there's actually a proposal of some text in front of us? Because right now we're having the charter discussion. We're already charted, and we actually have some issues to close that on the existing text. Is that okay?
Yeah.
All right.
Yeah. So if you aren't seeing the existing text, let us know.
Yeah. So I just had a logistical question regarding the three ones that I mentioned, and I think Andrew had a point which about maybe developing out the use cases for. Sorry, Andrew had a suggestion about developing out use cases and having text around these use cases. I just want to know how the chairs want to proceed in terms of doing that, because I'd offered to generate a pull request for a paragraph, and if you want to follow through in a different approach, I'm okay. Just tell me what you guys want to do.
Yeah, I think that's a good approach. By all means, propose text on the mailing list and in pull requests, and if that turns out not to work, then we can find another way.
Thank you.
So seeing no more comments, I will ask the last question from our agenda. Is there anybody who wants to volunteer to do something like write another draft beyond what we've already discussed here in terms of amendments to our current one draft? Okay. Seeing no volunteers.
Alex Mayhofer. I'm actually not volunteering to write yet another draft, but what I can see, we are currently facing quite a few different, I would say, extensions to the DNS way that we operate the DNS actually in DNS op. And I suppose that people would probably start to reflect those additions, let me put it that way, to the DNS protocol back into DNS over HTTP as soon as this protocol gets traction. Yeah. So things like extended response codes, yeah, that we are discussing in DNS op right now. I mean, it is essentially an eDNS 0 option, but it has a couple of implications that go actually beyond poor proxying of the DNS contents. So I suppose from that direction, we're going to see like a couple of copies of things that go on in DNS op.
So Paul Hoffman responding to that, it is our belief currently that it is wire format. So anything that comes and goes, and the receiver of the wire format should be acting like a stub resolver, possibly a newish stub resolver with things like that. If you see things that tickle that, please send them to the list. I think that there might be a short list. I hope the list is 0 length, but if we're wrong, it would be good to see those. But our current intention and what it says specifically in the current draft is it's wire format, including eDNS, whatever. So, but that means, just like you're saying, that stale response, we have a bunch of things sort of in flight in DNS op, but those all expect the receiver to do something different, and the receiver of this data would do something different. We're not expecting the server, the one who's encapsulating the wire format and pushing it down, to do anything different, including on the TTL stuff. That comes up in the same way.
Hi, I'm Andrew Sullivan. Coming back to the question from the chairs about drafts, I'm not here to volunteer to write a draft because I feel like it may be premature. I think what I was trying to suggest earlier was that maybe what we need are a bunch of threads on the mailing list first to sort of figure out, look, are there things here that could coalesce into something that could be a draft. At the moment, I think, if we try to write this down, it's just going to be incoherent. And we got too many things to work out. It was very obvious from this discussion today that there's a whole bunch of things that are big gaps. And if we could narrow this down a little bit in discussion on the list or an interim or anything like that, I think that would be more useful than trying to write a draft that is just full of holes.
So I just want to agree that I don't think it should be inferred that if at the end of the session we have nobody saying, oh, let's do another draft, that doesn't mean that the working group is concluded just when the one draft is concluded. We're still exploring the area and we're not likely to come to conclusions about it in this session.
Mark Nottingham, could you scroll all the way to the bottom? One of the real charms of this charter when it went around was the very short timeline. And I think that sold this working group to a lot of people. I would suggest that maybe we keep the document list very short, as short and close to one as possible. Having said that, from what I'm hearing here, I'm certainly not volunteering, although I can put some effort in. It might be helpful if there were a throwaway ID or a wiki page or something describing what people think the use case for this protocol is. I know we've kind of avoided that till now because we have a lot of different. Is it in the document?
Yeah, absolutely. I would have never agreed to do this with Patrick without a use case. Yeah, it's right up in front. And so if that's wrong, we should fix it, but it's right there up in front.
Okay, I'll take another look at it then. Okay, thanks. Never mind. Sorry. Keep it short.
My impression is that we are done. Is that right?
We still have time.
The SAG meeting over in the other room is about to get to an agenda in their security dispatch section on OCSP over DNS. So people who are interested in this multi-layer thing might want to go there.
Yeah, we'll call it. I think we are done with discussion for now. So if you want to pop over to SAG, feel free.
If I synthesize everything I've learned at this IETF, we could do OCSP over DNS over HTTP over TLS over HTTP over TLS over
You forgot
UDP?
Quick.
Quick over UDP.
Yeah. Over quick, yes.
Please remember to sign the blue sheets. If you haven't signed them, we have them waiting for you here up front.
Yeah. Okay. Oh. Do you want to go to this? No, I don't. I don't necessarily want to go there. Yes. Yeah.